Hey everyone, I'm heading over to my studio to record a video for you, and that video is about age confounding. That's a super important concept in epidemiology and absolutely crucial if you want to understand the scientific literature. So enjoy. We often use mortality rates in order to compare their development over time or between communities. This is important when evaluating the effectiveness of an intervention, a before-after comparison, so to speak, and for resource allocation, if we have to decide if one community should get the resources over another one. One problem with comparing crude mortality rates between time periods, communities, or whatever groups you're comparing is that these groups usually have a different age distribution, and age is the strongest predictor of death. Let's compare two populations again. City A has a population of 1 million inhabitants, and so does City B. In City A, 1,588 people died, whereas in City B, 995 people died. Let's calculate the death rates per 100,000 population. 1,588 divided by 1 million times 100,000 equals a death rate per 100,000 of 159. And 995 divided by 1 million times 100,000 equals a rounded death rate of 100 per 100,000. So it looks like the mortality rate in City A is much higher than in City B. In other words, the risk of death seems to be much higher in City A. But we said that this calculation does not factor in the age distribution of both cities. So let's look at the age-specific death rates in both of them. Now you see a very different picture. The age-specific death rates are actually higher in City B for all age strata. 19 versus 15 for the age group of 20 to 39-year-olds, 140 versus 120 for the 40 to 59-year-olds, and 270 versus 250 for the age group of 60 years and above. So why in the world is the overall mortality rate higher in City A, whereas all age-specific death rates are higher in City B? Well, because of the age distribution. As you can see, City A is way older. 50% are 60 or above. 1/4 is 40 to 59, and 1/4 is 20 to 39. In City B, on the other hand, only 1/5 is 60 or above. 1/4 is 40 to 59, and over half are 20 to 39. So actually, the risk of death is higher in City B. But because of the older age distribution in City A, more people died in City A, which is reflected in the overall mortality rate. So the key learning of this lesson is, whenever you want to get a quick grasp of the effect of age on your rates, compare the age stratified rates. In fact, you could do this for any potential confounder. If you thought that gender was confounding your overall rates, compare the gender stratified or gender specific rates. If you thought that income confounded your rates, look at the income stratified rates, and so forth. Okay, so I hope you liked the video. I'm off to grab a coffee. And if you liked the video, please leave a comment. If you didn't like the video, also leave a comment, and I talk to you soon. Take care.